So now that we have this formula, right, this great new tool added to our toolbox, let's see how we can use this thing to actually solve some equations. So I've got an example here for us to start with. 3x squared plus 5x plus 1 equals 0. And to use this quadratic formula thing, the first step is identifying what the values of a, b, and c are. So those values come right from the equation here. The first number here, the 3, is a, b is 5, and c is 1. All right, so let's just substitute those numbers into the equation. This becomes negative 5 plus or minus the square root of 5 squared minus 4 times 3 times 1 all over 2 times 3. You see, now this is just an arithmetic problem. All I have to do is simplify this expression, and I should get my answer. So the negative 5 stays where it is, plus or minus, this is the square root of 25 minus 12 over 6. 25 minus 12 is 13 over 6, and that's it. We're done. There's my answer. Right? You kind of see some of the power of this formula, right? It can get us answers really quickly sometimes, even more quickly than the factoring method did. All right, so let's look at another example here. Take a look at this thing. Now here you got to be careful. This is another one of those math is a very literal thing kind of issues. When we derived the quadratic formula, it started off with ax squared plus bx plus c equals 0. So to use the equation, I have to get to use the formula, I have to get my equation into that shape. Just like every other time we've solved a polynomial equation, I have to start off with it equal to 0. All right, so let's do that. I'm going to subtract 5x from both sides, x squared minus 5x, and let's add 4 to both sides. Also, plus 4 equals 0, and that's what I needed. Now I can get my values. C is going to be 4, B is going to be negative 5, and A, I know it looks like there's not a number there, right? But there is, right? There's always kind of that implied 1. So when there's no visible number in front of it, that's okay. That parameter is just going to be 1. So let's put these numbers in here. X equals, careful now, negative 5 plus or minus the square root of negative 5 squared. Add those parentheses. Right? That's going to be important here in a minute. Minus 4 times 1 times 4, square root of this, over 2 times 1. All right, so let's negative 5, that's plus 5, plus or minus negative 5 squared. You see why I said it was important to get the parentheses there? You have to see that this is negative 5 times negative 5. So this is positive 25 minus 16 over 2. All right, 5 plus or minus the square root of 25 minus 16, that's 9 over 2. And that now this one I can take further, right? 9 is square root of 9 is 3. So this is 5 plus or minus 3 over 2. Now I'm not going to stop here, right? Because I got rid of the square root. I got this down to actual integers. I'm going to keep this going, right? I'm going to actually write out these two separate answers. This is 5 plus 3 divided by 2, and 5 minus 3 divided by 2. So let's see, 5 plus 3 is 8, divided by 2 is 4. 5 minus 3 is 2, divided by 2 is 1. There's my final answers. Right? X equals 4 or 1. Now when this happens, this makes me think, okay, wait a minute, time out. The fact that these numbers came out, that the answers came out nice like this, that says to me, you know what, I probably could have factored this thing. Right? If you go back, take a look at the original equation over here. This is x minus 4 times x minus 1. So yeah, I could have factored it, but it doesn't matter. The formula works no matter what the answers are, right? So the way I usually kind of approach these kinds of quadratic equations, I'll take about 20 seconds trying to factor it. And that's all the time I'll invest. If I get to that 20-second point and I haven't seen how this thing factors yet, I'm not going to spend any more time. Go to the formula. Put your numbers in, and maybe you'll see, oh, yeah, okay, I could have factored it. Maybe not. Doesn't matter. You're going to end up with the right answer. All right, so I've got one here for you to practice with. Right, go ahead and pause the presentation if you like. See if you can't work this out on your own. Then start it up again, and we'll go over it together. All right, so first I got to make this equal to 0. So let's subtract 2 from both sides. That makes my equation x squared plus 4x minus 2 equals 0. So my a value is 1, my b value is 4, and my c value is negative 2. Great, let's go to the equation now. Negative 4 plus or minus the square root of 4 squared minus 4 times 1 times negative 2 over 2 times 1. Now we'll start simplifying. The negative 4 is just going to kind of stay there. Plus or minus the square root of 16 plus 8 over 2, which is negative 4 plus or minus the square root of 24 over 2. And now I'm not done. Right? I'm not quite done yet this time, because I'm looking at that 24 and I'm thinking I can probably simplify that. All right, so let me jump up here. Right? I'm going to rewrite this a little bit. X equals negative 4 plus or minus the square root of 24. Let's see, that's 4 times 6 over 2. See, now I can keep going. This is negative 4 plus or minus the square root of 4. That's 2. So this is 2 times the square root of 6 over 2. And now I'm thinking I can go even further, because both of the terms on the top, I can factor a 2 out. So this becomes 2 times negative 2 plus or minus the square root of 6 over 2. The 2's cancel. And now I get my final answer, negative 2 plus or minus the square root of 6. So you always have to do that little stop at the end when you think you're done, right? And ask yourself, can I simplify this further? Because we're always looking for that most simplified version for the final answer. All right, I've got one more here for us to look at, and this one, it's got a fraction. All right, so first, let's not worry about the fraction just yet. First, I have to make this equal to 0. So let's subtract 6 from both sides, and the equation becomes 3x squared plus 1/2 x minus 6 equals 0. Now look, the quadratic formula doesn't care. Doesn't care from fractions, doesn't care from decimals. You know, these quadratic equations, they show up a lot in kind of basic kinematics questions. It's the study of motion that you do usually at the beginning of a physics class. And the physics guys, they got decimal numbers everywhere. And the quadratic formula doesn't care. You can put decimals in, you can put fractions in, you can put square roots in. It's going to work no matter what. Just speaking for myself. If I put 1/2 in there for b, I'm going to have a fraction here. I'm going to have a fraction here with a different denominator. Then I'm going to have to find a common denominator to add to that for AC. And look, I don't have a problem with working with fractions if I have to work with fractions. But it's adding steps to the problem. And every step I add is another opportunity to make some silly arithmetic mistake that kind of screws up my final answer. So here's what I'm going to do. I'm just going to take this equation here. I'm going to multiply both sides by 2. All right, so you see when I distribute here, 2 times 3, that's 6x squared. Here, 2 times 1/2 is 1. So this just becomes plus 6 minus 12 equals 0. Yeah, okay, the number's got a little bit bigger, but I'd rather deal with a big number than have to stick fractions in there, in particular for that b parameter. So let's put my numbers in here now. X equals negative 1 plus or minus the square root of 1 squared minus 4 times 6 times negative 12 over 2 times 6. So do inside the square root here. This is the square root of 1 plus 6 times 4 is 24. 24 times 12 is, I believe, 288 over 12. Now we'll add these together, right? Negative 1 plus or minus the square root of 289 over 12. And that's it. There's my answer. Right? I'm pretty sure we can't break that 289 down any further. Multiples of 3 don't go into it. Multiples of 4 don't go into it. 25 doesn't. 49 I don't think is good. Yeah, I'm pretty sure we're done there. Right? That 289, we can't go further. All right, so these are the kind of situations that come up with the quadratic formula. Very, very important tool if you're taking any math class after whatever you're taking now. You really need to start doing a lot of practice questions with these, because that's what's going to help you commit that formula to memory, where you're really going to kind of need it to be. So we do have one more lecture on this quadratic formula. The situation where the thing under the square root becomes negative, right, and we end up with an imaginary answer. So that's kind of the one last case we need to look at, and we'll do that in the next slide. No, the next lecture.